know that the mean property is satisfied. It's a kind of process in which things do not depend on history. It depends on present and past. So how can I conclude it? Can I say that this is same as saying this is same as saying this is same as saying so I'm talking about this. Yeah. So I'm talking about going kind of a recall. What? So how can I compute the probability of intersection of the dual set? So I know I can compute them from the conditional probability. What will be the actual? Which is same as saying that probability A given B that's like by
probability.
So I'm going to write the formula just to structure. So can I say that this is same as the same thing? Right? This same thing given. So let me write it in another manner. So x follows is x naught x set in this pattern. Given that probability that x follows follows x naught xn minus 1 multiplied by probability that x follows what? X naught xn minus 1, and by x I mean you see what I'm doing this basically. Another action. When I'm saying x follows x naught by xn, I mean this. And I'm saying that probability that this will happen is equal to the probability that this will happen given that up to xn minus 1 this has happened multiplied by the now what can I say about this guy now? If I say xn is a Markov chain, this would be same as saying that probability that x is xn given what? Xn minus 1 is xn minus 1. You see that? You see that it should be the same as frequency. It's a memoryless process. Time, what can I do with this? What can I do with this? So I'm going to do the same what I did with this side. So can you see where I'm heading at? So I want to write this as the product of the conditional probability. So can you predict what would be my end result? So the next should be okay. Should be probability xn minus 1 given xn minus 2, xn minus 1 is xn minus 1, xn minus 2, so on and so forth, and finally you can have probability that x1 is x1 given x1. Okay. You get it now? So what's a good thing about the, what's a beautiful thing about this formula? So what immediately benefits this formula is given? So the immediate benefit it gives to you that you can compute such probabilities by just looking at your transition matrix. Let's think about it. We have Markov chain and the transition matrix, whether it's let's say the entries from your transaction matrix analysis that means questions. So we talk about such events. Directly forms the transaction matrix. Okay. So if I say same,
is there any other way so that we can compute the probability?
the other way is that you need to this is the question that I must ask from you because you have done some probability. The other way is that you need to have, in order to compute such probabilities, you need to have the joint PDF of all these random variables actually. X naught to Xn. So if you have joint PDF, so basically what we are doing, you are evaluating the mass function of a finite number of random variables in the terms of these simple condition probability. So the other way is that you should have the mass function. So you should know the distribution. So essentially what we are doing that basically you are kind of computing the joint PDFs of the finite number of, for example, random variables, okay, by simply introduction. So the other way is computing the variables. Can you see that? And we know that if I want to compute this, this would be a difficult task because first I need to know the distribution of each of the function. If these are independent, maybe then it's very easy that the probabilities is going to be the product of probabilities. Okay. And if they are not independent, it's very messy. That's why you invented what you call this measure theoretic probability to deal with such kind of situations. Can you think this? But in case of Markov chain, this is very so in this chain, for example, if I ask from you, what is the probability that day is wet, okay, and tomorrow will be wet, and day after tomorrow, okay, it will be dry, and day after tomorrow, it's going to be better. So it's like looking at today's weather and predicting the weather of upcoming days. So how are you going to compute it? And imagine you know the transition matrix. So the transition matrix for this is going to be just writing it directly. You may verify it. So it's going to be 3, 4, 1, 4, 2, 3, and 1, 3. Okay. So it should be same as? So it should be, okay. What would be the formula?
Product of weight to weight, P is weight to weight.
Product of?
Weight to weight now.
Weight to weight.
Then weight to
probabilities.
And so what is H2? What do you want? Weight to dry, WD.
WD.
And dry to
WD.
Dry to weight, DW.
Dry to dry.
Is it?
You know the transition matrix? You know it. You can answer many questions out. The next thing is so the transition matrix basically simple. This transition matrix P is basically a way to compute the probabilities from one state to another state, but in one step actually. Question. Can I, and you saw, for example, this example, that using these transition probabilities, you can make a prediction about the upcoming years for me. Okay. The question is, can I make a prediction about the upcoming 10 days, 20 days? Answer yes. Let's do it. We know for that we need to know this transition matrix. The question is, can I compute this transition matrix from the simple transition matrix of the theorem, what do we call it? Markov genome. The answer is yes. And the answer comes from something what we call the Chapman Kolmogorov equation. One of the beautiful, simple result, very beautiful result, that basically allows you to compute the n-step transition probabilities, okay, using the transition probabilities. That is called Chapman Kolmogorov. Theorem essentially what are we talking? Okay. So what are this? So it says that it's an n-step transition matrix. The matrix satisfies this equation. So the right equation in two forms. The first one you need the matrix form. Let's take the transition n plus m steps transition matrix. This transition matrix can simply be obtained by multiplying the nth step transition matrix times the nth step transition matrix. What would be the local picture of this equation? In other words, what would be an abstract entry of this matrix? And how can I write it in terms of this product? So, how does the abstract entry is going to look like? So, it's going to be Bij. The probability you are in the state A and will be in the state J after the n plus m steps. So it should be what? So I need to
N plus one minus one.
how do you write if you have product of two matrices? So just think about it for this. So it's gonna be sum. Okay? The entry from Pn, so it's going to look like Pi, for example, K, okay, in n step times
Pk and
Pk J step, where K K is what? The number of entries you have in the transition matrix. Can you see this? Isn't that so you will see actually that what miracles is very simple equation can be done. These equations are called by Chapman Kolmogorov equation. So why this should be true? So what do I mean by explicitly? What is an explicit meaning of this Bij plus m? What do you mean by that? Imagine begin from the I. Okay. and you reach, so this is the probability that you start from the I. So this 0 is not necessary, it could be anything actually. You can take K actually, doesn't matter. So that you start from I, and after the N steps, you end up in J. So I'm interested in this probability. By the way, what is the explicit meaning of this? So, what is the meaning of when I'm saying that probability that Xn is I? What is the more careful description of this?
Probability of Xn is less than or equal to I. Probability of Xn is less than or equal to I.
So, I'm asking a more sophisticated description. More sophisticated description is because, I know probability is a measure. So it works on the sets, not on the equations.
Yeah.
So what is the set sitting behind this equation actually? Since the collection of those omegas, always the Xn of omega is I. Okay? That's what it means that you have to keep on reminding you this. So you have it. The question is, what would be some alternate way to write this event actually? Xn plus 1, Xn plus 1, and J. So at Xn plus M, I'm at J. And X naught, I am at I. Okay. And say at Xk, where k is something, anything else than not N plus M. Maybe that's right, Xn on the N moment. Okay. Flip moment or frequency N moment. So N will be. So in other words, when you are reaching to N plus M, you must have passed through N. The question is, in what state you could be on the N state? I have no idea. So I can put a K. Okay. And how can I say that this state K can be anything from the state to space? So what you can do, just write it as with mean of K being this in a system. Can you see that this is same as this? But on the nth step, you can be in any state K. So I don't know which state it is. Some state K. You mean that's what it is. So we know that this P is a probability measure. So what can I do with this? What can I do with this? So this is same as saying that the sum of the K in S, probability that I am Xn plus on the Xn plus M moment, I'm in state J, I'm on the nth moment, I was in K, and given that I started with I. Okay.
Those units are satisfied.
Sorry?
Those units are satisfied.
Which one?
With inside.
These should be. Why? Because the process can be in only one state, and can't be dry and wet at the same time. These are the things that you can reflect upon. So, what can I do with this guy? What can I do with this guy? So, I can play a little game with this expression, and I can say this is the same as Ks, and probability that on n plus mth step I am in the state J, and on the nth step I am in the state K and at naught wasn't I, given that at naught wasn't I, times probability that the extent and the nth instant I wasn't K, given that I started from I. So we should be having three making sense of this exceptional. So it's just rewriting the same probability. Usually this why this should be true. This simple condition definition of conditional confidence. It's not something. Okay. What would be the final expression that we're going to have? So if you simplify it. So what I wanted actually. So okay. So I'm done. This represents what? So this represents I am in P I K. So I reach from I to K this step and then starts. So how about this one?
You are in N, and you are reaching at N plus 1, N plus 1.
So if you
It's
should be the same as
saying
that
let K, you are at Q.
let me write this. This is same as saying that it's n plus m j k equal to n plus on the n plus nth movement you will be in the state k given that
J is a
in j given that at xn you are in
Q.
k and with times p I k. Can you see this? Why this should be good? Okay. And once you have it, this is precisely what you want. You see why this expression or this probability is similar to this probability. But it's a key thing that is plainly proved. Okay. Good time to brush up your basic identities and conditional probability. Okay. So what we got? We got Chapman Kolmogorov equations. Okay. And now let's see some benefits of this equation. These two parts are other than. What would be the consequence of it when when n and m are equal actually? Say one of the instant is 0. One of the n and m is 0. You have only
Power of the matrix.
in Chapman Kolmogorov equation, you have n plus m. So inside take m to be 0.
प्रोडक्ट तो जीरो हो जाएगा
And then
So means we are at initial stage and we want to reach it.
so if from the marks, for example, so I'm putting the mark in that. Now I can talk about what will be the meaning of this. So what will be the meaning of this? Simply multiply the transition probabilities n times. Simply multiply the transition probabilities n times. Which is not now. Okay, so Another good thing. Once you have transition probability, you can easily compute such probabilities as well. You don't have to do a new kind of analysis, you just have to simply multiply probabilities. Okay. So, what would be, that weather example, very simple knowledge of change. So, I have, what was the peak in that case? That was this one. It was 3/4, 1/4, third. So this is basically, these are the probabilities that how weather changes from, day 1 to day 2, right? 1 day to other day, R to R, instant to instant. So now I'm asking the question, what would be the different kind of probabilities? What would be the what would be the weather after the 2 days? Maybe 3 days. So what do you need to do?
P square P.
Just take P and square. Okay. So we're going to compute P square. Okay. We're going to get these numbers 35 by 48 and 13 by 48. It's like 13 by 18 and 5 by 18. So what would be the interpretation of this entry? The interpretation of this entry is going to be today is wet, for example.
After 2 days.
And after 2 days,
It would be wet.
it would be wet again.
With the probability.
In this probability. 13 by 48. Today is wet and after 2 days it's going to be dry. So you can have lots of fun with the transition matrix. And in some sense, this allows you also do what? To know the behavior of the Markov chain in long run. When it would be, what would be the situations when it would be very easy to, for example, predict the behavior of the Markov chain in long run? Can you use your previous mathematical skills where you learned something about matrices?
Diagonal matrix is
Diagonal matrix. So if your matrix is diagonal, or at least diagonalizable, okay, then it's very easy to compute the long run probabilities. But we know diagonality and diagonalizability is a very rare condition. Not every matrix is diagonal. And we have this other ways of Jordan normal forms. These forms are great. If you are lucky enough, if transition matrix is diagonalizable, you are in good hands, and you can talk about very long-term probabilities as well. Okay. But the interesting question would be, can I take this and to infinity? The answer is, if you want to take this n to infinity, then you want to study, what's going to happen, very long time actually, then you have to study the structure or the dynamics of the Markov chain. So it depends on the structure of the Markov, what kind of chain we are talking about. So not every chain can be studied in long run. Yes, basically studied, interested in its long-term behavior of. Alright, so let's move on and let's, for example, one